Okay, so your first section is called Advanced Right Angle Trigonometry. So this shouldn't be anything that you haven't already done before. For those of you that have had pre-cal, you did this in pre-cal, and for those of you that have had Algebra 2 only, you did this in Algebra 2. And pre-cal, of course, you did it in both. So I'm recording this video at home, so hopefully everything turns out okay. The other videos will be recorded at school like normal. So a trigonomic ratio, you need to remember that it is a ratio, which means it's a fraction. Depending on what your ratio is will determine which sides you're using for that. But something to keep in mind is that this is right angle trigonometry. So later in this chapter we'll do non-right angle trigonometry, but all of these involve a triangle that does have a right angle. So first we have SOHCAHTOA, which is a way that you can use to remember the three different ratios that we're going to deal with. In IB math, we only use sine, cosine, and tangent. We don't use cosecant, secant, and cotangent if you've done those before. SOHCAHTOA can be a great way to remember them. The only bad thing about that is sometimes people spell it wrong. So in whatever way you can use to remember that, anything kind of silly. My teacher taught me Tom's old aunt sat on her cat and hollered, just using those same, sets of three letters. I've told other students before because it was kind of silly and they remembered it. Let's see if I can remember it. Some old hippie caught another hippie tripping on acid. So, that's a little catchy there. Anything that you can think of to try to remember those. I don't remember if those are in your formula booklet or not. Let me pause this here just for a minute and look that up. Okay, those ratios are not in your formula booklet, so you will need to make sure that you remember those. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now sometimes students get adjacent and opposite mixed up, so you want to be careful about those. The hypotenuse, of course, is the side that is across from the right angle. And then that leaves the opposite and the adjacent. So we're using theta. Theta is a special Greek letter that's used primarily for angles. So let me erase this here a little bit. So the side that you could actually draw an arrow to is the opposite side, and then the side that helps make up that actual angle would be the adjacent. Of course, the hypotenuse is the other side of that. So you really want to make sure that you get those down. Don't memorize that adjacent's always the bottom and opposite's always the left-hand side, because, of course, it depends on the way the triangle is oriented. If you look at the triangles down at the bottom of the page, they don't look exactly the same necessarily as this triangle here. So first type of things you're going to have to be doing in your homework is just actually writing the ratios. So little example right here. Of course, in this triangle, we already have all three sides. Don't assume that that's going to be the case. You might have to find a missing side, which with a right triangle, we can use Pythagorean theorem. So my sine is the opposite of our hypotenuse. So in this case here, this is my hypotenuse. We can just label that with an H. Again, the side that you can draw an arrow to, that's your opposite side, and the other side is your adjacent. So for sine, opposite over hypotenuse, that's going to be 14 over 50, and then reduce that. Always you want to reduce, so 7 over 25. Cosine, adjacent over hypotenuse, that's 48 over 50, is 24 out of 25, and then tangent, opposite over adjacent, 14 out of 48, and 7 24s. Now, if they did give, let's say that this triangle had letters on it, and let's say that it was triangle X, Y, Z. So if they were asking you to do this instead of angle theta, they were asking you to do it for angle Z, you'd have all the same answers. But then if they switched and asked you to do it for angle Y, then the opposite and the adjacent sides would switch. So just be aware that once you label a triangle, you're good only for one particular angle. If you switch angles, then you're going to have to switch which side is your opposite and which side is your adjacent. Okay. So, an example here, find the value of the sine, cosine, and tangent. So let's put some numbers on these triangles here. This would be my right angle. So let's call this 6, and let's call this side here 10. Well, of course, I'm missing my opposite side right here. Let's put an X right here. And let's call this angle right here theta. Okay. So I would have to do the Pythagorean theorem. Now, I'm actually going to write this over to the right because I don't have a lot of room and the stylus is being a little finicky. So that would be x squared plus 6 squared is equal to 10 squared. I don't know if the Pythagorean theorem is in your formula booklet or not, but honestly, it really shouldn't need to be. You should be able to do this on your own. Be careful about the Pythagorean theorem. Remember that the hypotenuse is always on the side by itself. It's not always just going to be the two numbers that they're given to you squared equals the unknown. Depends on which one side is the unknown. So in this case, x squared would be equal to, I'm going to do a little shortcut here. That's going to be 100 minus 36. So that's going to be 64. So x is going to be 8. Now, they would want that to be exact. So if you can't take the square root of 64, then break that down if you can, but leave it as a square root. So let's go back here then, and let's replace this x. Actually, we won't replace it. We'll just write x is equal to 8 there. So according to this triangle here, let's change colors here. So here would be the side that I can draw an arrow to. So this is my opposite, this is my hypotenuse, and this is my adjacent. So sine is opposite over hypotenuse. That's going to be 8/10. Reduce that, that's going to be 4/5. The adjacent over hypotenuse, that's going to be 6/10, or 3/5. And then the tangent, opposite over adjacent, that's going to be 8/6. Now, in trig ratios, don't write them as a mixed number. You always want to leave it as an improper fraction if that's what it turns out to be. So in this case, that's going to be 4/3. And again, leave it as 4/3. Okay. Now, over here on the other side, let me see, I think this is my, here we go, that's my eraser here. Okay, so on this other side here, we'll label this triangle. So let's call this side 2 and let's call this side 3. And we don't know the other side here. So call that x. So in this case, that's going to be 2 squared plus 3 squared is equal to x squared. So that's kind of what you would think it would be set up as. But again, that's only in this case because the fact is that my unknown is the hypotenuse, and that's on the side by itself. So 4 plus 9 is equal to x squared. So x is equal to the square root of 13. Now, in both of these, finding the missing side, I did skip a few steps. Be careful about doing that. The math is pretty easy, but you want to make sure you don't make a silly mistake in that arithmetic there. So the square root of 13, I'm going to go ahead and erase that so I can have room to put that in over here. And this is all filled out on my website too if you need to see something again. So square root of 13. Now, you don't have to label with opposite and adjacent and all that, but it can be kind of helpful. This is hypotenuse. I'll tell you what, let's call this my theta in this case, just to make it a little bit different than what we were doing on the other examples here. So this is the side I can draw an arrow to, so this is my opposite, and then this is my adjacent. So in this case, my sine, I don't have the opposite over hypotenuse written, but feel free to do that if it's helpful to you. I definitely feel like on your quiz, on your test, and on your homework for that matter, you should actually write out these definitions. However it is that you're remembering them, write them on your paper rather than trying to pull them from your memory every time you use them. So sine is opposite over hypotenuse, so that's going to be 3 over the square root of 13. Now, normally when we have that square root of 13 on the bottom, we would rationalize that. We would take care of that radical there. Now, you may find in some situations they actually leave that as 3 over the square root of 13. We don't normally leave a square root on the bottom of the fraction, but in IB, they'll let you get away with it. The only thing is, if you can break the 13 down, you do need to make sure that you do that, but I can't break 13 down into anything that I can take a square root of. Now, just in case you are needing to rationalize it for maybe, let's say, for the SAT, the ACT, whatever, PSAT, let's go ahead and just review how to do that. So we would multiply the top and the bottom by that square root of 13. So on top, I would have 3 over the square root of 13. On the bottom, when you take the square root of 13 times the square root of 13, that's just going to be 13. Now, the 3 in the front of the radical and the 13 underneath, if you can reduce those, make sure that you do that. 3 and 13 don't have any common factors, so we just leave it. Okay. Cosine, that would be 2 over the square root of 13. And you would simplify that in a similar way. But again, the IB will let you get away with it, so we can just leave it the way that it is. And then tangent, that's going to be opposite over adjacent, so 3/2. And again, don't write it as 1.5. Leave it, just reduce there, and 3/2 is as much as I can do. Okay? All right, so that's the first page here. Let me see if it'll let me switch to the next page here. Well, oh, here we go. Okay. All right, just a reminder about rationalizing. So if you have something like the square root of 12, you can do it with a factor tree if that's how you learn to do it. Personally, I don't like doing it that way. I think, is there a number I can divide into 12 that I can take a radical of? So in my case, that was 4, and 4 times 3 is 12. I can take the square root of 4, which is 2, so 2, square root of 3. Be careful again about doing that in your head. Sometimes when people do that, they end up putting the wrong number under the radical, and they might give this answer as 3 square root of 2, which obviously is backwards. Also, if you do have a side there that has a radical in it and you need to square it, make sure you square both parts. That would just be like if you were taking 4x and squaring it, you have to square the 4 and the x. Same thing with 4 square root of 3. So you square the 4 and you square the square root of 3, and you end up eventually with 48. Now, whenever we solve equations with trig, you want to first of all figure out what sides am I dealing with here. That's going to help you figure out which trig ratio to use. Also in this course, we will always be in degree mode. So with your graphing calculator, make sure that is in degree mode. Radian is kind of the default. So as long as you change it, it should stay in degree mode, and let me know if you need help with that, but essentially you just hit the mode button. If you're using a scientific calculator, those can also switch modes. Again, just let me know if you need help figuring out how to change that. So for the first one here, find the value of x. We're going to give our answers to 3 sig figs. So first of all, again, figure out which sides I'm dealing with here. So they've given me an angle of 53. So this would be my opposite. This, of course, would be my hypotenuse. So opposite and hypotenuse, that's going to be sine. So the sine of 53 is equal to x over 15. So I'm just going to try to do something there. Well, let me do it. And then now you want to solve that. So I want to get rid of that fraction. I'm going to multiply both sides by 15. And then you just type that in your calculator exactly the way that it looks. So 15 sine of 53, hit enter. You end up with x is approximately 11.9795. We want to do 3 sig figs. So the 9 would be the last sig fig, but I need to round that. So the 7 is going to make the 9 round up, which is going to make the 11 round up. So x is equal to 12.0. Do write the 0.0, that way people know that you rounded to 3 significant figures. Okay. Now for B, again, evaluating what I'm given here. This is my opposite. This is my adjacent. So that's going to be tangent. So tangent, right here, tangent of 67 is equal to 24 over x. Okay, now this one's a little bit harder to solve. Again, I want to get rid of the fraction, so we're going to multiply both sides by x. But I'm not ready to put that in the calculator yet. I want to get the x by itself. So x is going to equal 24 divided by the tangent of 67. Please don't try to memorize how it's going to end up at the end. Just do the math, okay? So we type that in the calculator exactly the way that it looks. Again, 24 divided by the tangent of 67. And I end up with x is approximately 10.2. 2. Now, you don't have to write approximately, but I just wanted you to know that it wasn't exactly 10.2. Okay. Now, last basic trig one here, and then we got a couple others, and we'll be done. So in this case, I actually have all 3 sides. So in this scenario, I could use any of my trig functions. The reason why, though, this one is different is because I'm actually looking for an angle. So again, in most situations, you're not going to necessarily have all 3 sides. So again, you would evaluate which 2 sides do I have, what trig function is that going to be. In this case, since we haven't done cosine yet, let's do this as cosine. So in this case, this would be my opposite, my adjacent, and my hypotenuse. So I'm going to, again, think of this as cosine, just because we haven't used it yet. So the cosine of angle C would be 8 over 10. Now, I can reduce that, but that's not my final answer, so it doesn't really matter. Whenever you're trying to find an angle, when you're doing trig, you're going to use an inverse. So that's where you hit the second button. So this is going to be the inverse cosine of 8/10. And that's what you're going to put in your calculator. That's going to give me C. I don't need you to write that step down, but I just wanted to make sure you knew that that's what we're doing. So that's what you're going to type in the calculator. Again, you can reduce it if you want to, but there's no reason. You'll get the same answer leaving it unreduced. I end up with C is approximately 36.9 degrees. Okay. Again, anytime you do an inverse, you're going to end up with an answer in degrees because we're always in degree mode. Okay, so that's going to be the majority of your questions in your homework. Now, there's a couple other little bit more complicated questions that I wanted to make sure that you were okay with. Okay, so A, we are going to later be doing law of sine, so you might kind of remember this kind of scenario. But just in case, anytime you have a fraction on both sides like this, you can totally just cross multiply, which is what I'm going to do. So we end up with x sine of 33 is equal to 4 sine of 46. Now in this case, I want to divide both sides by the sine of 33. Now I'm going to put that in a parenthesis, and I'll tell you why here in just a minute. Now, be careful about this step that I just did here. The sine of 33 is a number. It's just a super yucky number, but it is multiplied times x. So to get the x by itself, you would need to divide both sides by it. Now, the reason that I put the 46 and the 33 in a parenthesis is because whenever you put this in the calculator and you type in 4 sine of 46, it's going to pop up a parenthesis. You have to close that parenthesis on the 46. If you don't, and you go ahead and do divided by the sine of 33, it's only going to divide 46 by the sine of 33 instead of dividing that entire top by the sine of 33. So anytime your calculator pops up a parenthesis, just close it. In some cases it may not matter, but in some cases it will. So it's better safe than sorry. Or if you're really worried about it, do the 4 sine of 46 and hit enter, and then immediately divide by the sine of 33, and you'll be good. Either way, in this case, we should end up with that x is approximately equal to 5.28. Okay. Now, for B, there's a couple different ways that I could do B here. I can distribute the 1/3 into the parenthesis. I could do that, but I can't really distribute it nicely because the 4 won't divide by 3, which is essentially what multiplying by 1/3 will do. So let's just multiply both sides by 3, and that'll get rid of the fraction on the right-hand side. Of course, I have to multiply it on both sides because otherwise my equation will be unequal. If I take the left side times 3, that's going to be 18 cosine of 48. Now, don't take the 48 times 3. That's just one thing, the 6 cosines. So think of it as I have 6 cosines of 48. If I take that times 3, now I have 18 cosines of 48. And then on the other side now here, 3x minus 4. Now, you don't have to show as many steps as what I'm going to do here, but I want to make sure you understand what we're doing. You don't want to do any rounding until the end. So 18 cosine of 48 is going to be a super yucky number. So I'm just going to kind of carry that through my problem here. So 18 cosine of 48, I'm going to close that parenthesis because, of course, in your calculator there's going to be one there. Plus 4 is equal to 3x. And then I'm going to divide all of that by 3. 18 cosine of 48 plus 4, divide by 3. Now, be careful when you put this in the calculator. You need to do one of two things. You can do the top, hit enter, then divide by 3. If you're going to put it in your calculator all in one step, then you're going to have to put this entire top in a parenthesis. Now, why did I not do that on the last one with the 4 sine of 46? Because you're multiplying. Okay, so it's not a big deal. You can multiply and divide, and it's the order of operations. It's fine. If I don't put that top in a parenthesis in this scenario, it's only going to divide the 3 and the 4. So think about the way that would look. 18 cosine 48 plus 4 divided by 3. It's only going to divide the 4, which is obviously not what I want. So I type that in. I end up with it. X is approximately 5.35. Okay. So those solutions are all in Google Classroom. I went ahead and put it there because I figured you're going to be looking at the book there anyways. You're doing all of this lesson, but the questions will go really quick. Now, just since we're on this page, let me go ahead and go through some of this miscellaneous stuff. This is going to be stuff that's going to pop up throughout this chapter that you're going to need to know. So hopefully this is all stuff that you remember, but I know some of it's going to be new stuff. So isosceles triangles. Isosceles triangles have two congruent sides and they have two congruent angles. So just to draw you a quick picture here, these are your congruent sides, and the angles across from those are also congruent. So if they give you the angle up there at the top, you know those other two angles are congruent, so you can find those missing sides pretty easily. A linear pair, those are adjacent angles that that together form a line. Those add to 180, so that would be something like this. The angle here and the angle here together are 180. The height of any shape is a perpendicular segment. So, for example, if we talk about the height of this trapezoid, that's going to be right here. Okay. If we have, say, kind of an interesting looking triangle here, the height of that triangle would be right there. Okay. Regular polygons, a regular polygon means that all the sides and the angles are congruent. So think about a stop sign. As far as I know, every side on that stop sign is the same length, and that would be a regular octagon. A regular triangle, the special name for that is an equilateral triangle. All the sides are equal. And a regular quadrilateral is a square. All the sides are the same. Perimeter, some of your questions later on they'll ask you to find the perimeter. That's the distance around the outside of a figure. Even if you know some of the segments on the inside, don't use those. Perimeter is just the outside. In a circle, the special name for that is the circumference. Area, that's the measure of how much space is on a flat surface. Think about covering it in paper, in fabric, in paint. All of those things would be area. Those are in units squared. So perimeter would be feet, let's say, area would be feet squared. And then volume is the measure of how much 3D space a figure takes up. So think about how much would fit inside. If you have a cylinder, which is a 3D shape, like a can, how much would fit into that can. And that's going to be in units cubed. A really easy way to remember that, perimeter, you're adding up all the feet, so it's like just combining like terms. Area, you're multiplying feet times feet, so x times x is x squared, feet times feet is feet squared. Volume, you're multiplying feet times feet times feet, length times width times height, let's say. So feet times feet times feet, that's the same as x times x times x. That's going to be cubed. Okay. Another big thing for this chapter is going to be dealing with distance, rate, and time. More so rate. A lot of your questions in the coming sections are going to ask you to find a rate or to ask you to find a time. So I'm sure once upon a time you learned that distance is rate times time, or D equals R times T. You can manipulate that formula. Think about solving it. So if you want to solve that equation for rate, divide both sides by time. So rate is equal to distance divided by time. If you go back to this formula again and you want to solve that for time, divide both sides by rate. Okay. Now this is not in your formula booklet, so you need to know that distance is rate times time. Now your rate can be given in any unit. If they ask you to give a rate, you can give it in feet per second. You can give it in feet per minute. If they ask you for feet per second, but all you have are minutes, then you would need to convert those minutes into seconds. Now, they do sometimes write rates using negative exponents. So you have heard of rate of meters per second. You could also write that as meters divided by seconds, or meters per second to the -1 power. Now, the first time I saw that, that was kind of weird, but when you have an exponent to the negative power, you do normally put that in the bottom of a fraction, so it makes sense. Just a little weird. I don't care how you write it. If you write it the first way, say on your exam, they're going to know what that means because they know that that's how they write it in America. Okay. Last thing is about scientific notation. Now this is in chapter 2, I think, of your book. The rate is, I think, in chapter 1. So I did put those in Google Classroom under prior learning as your heading there. If you look a couple posts down or on the side there where it's sorted by topic, the prior learning topic, you can look this stuff up there if you need some extra practice. I know that you all dealt with scientific notation before. You can enter that in the calculator without converting it. So if they give you 4.53 times 10 in the -4, you type that in, and it would look like that. Now, depending on the mode of your calculator, it may not have the little house top in the -4. It might look just like what it does over here. Either way. Okay. Now, if your calculator gives you a number in scientific notation, it doesn't use the times 10 to the -4. It uses E. So this, in your calculator, would actually look like that. So just be aware, this is something that is in your standards for this class. So you're going to see some scientific notation stuff here and there. Now, if you need to convert something from scientific notation to standard or vice versa, remember that when you have a negative exponent, that's going to be a very small decimal. So that's going to be how many places you're going to move to the left to make that, smaller again. A positive exponent means you're going to move to that many places to the right, which means it's a big number. Numbers in scientific notation are written in the form A times 10 to the K. So just to go back up here again, this number would be something in scientific notation, A in this case being 4.53, K being that -4. The absolute value of your A is always between 1 and 10. K can be positive or negative. In our scenario here so far, it's been negative, the -4. But it cannot be a decimal. It has to be a whole number because it's how many decimal places you're moving. You can't move a decimal amount of decimal places. Your A value can be positive or negative. You can have a negative number in scientific notation, but it cannot, the absolute value of that has to be smaller than 10. They always want, when you move things into scientific notation, that first number there of that A value has to be a number less than 10. So you could be 9.99 times 10 to the whatever, but you can't be 10 times something to the whatever, because then you could just have one more number there on your K value. Okay, so all of these concepts are not going to really apply to this lesson. They're going to be more for the lessons to come, but we have some time to talk about it now. But expect to see this kind of stuff popping up. I don't know that you'll see any of it in tomorrow's section, but probably in section 3 and definitely in section 4, you'll see some of this stuff. Okay, so let me know if you've got any questions. You can shoot me an email. You can see me before class, after class, before school, after school, whatever works. And we'll have another video for you tomorrow. That one will be done on my smart board, so the video and the writing and everything should look nicer. So there you go. Your assignment, again, it's on my website, but you're doing all of the problems from this section. And that PDF of the book, if you want to use the PDF, is in your Google Classroom.